Hi, so in today's video we're going to solve integrals using trig substitution. So let's look at this table here. This table tells us that if you have this expression, that you're going to use this for your substitution. If you have this expression, then you're going to assign x as this substitution, and if you have this expression in your denominator, then you're going to assign x as this substitution. So if we look at this example, the integral of 1 over x squared times the square root of x squared minus 4, the first thing we want to do is identify which expression of these three is most similar to the one seen in the denominator. So if we look closely, we can identify that this last expression here closely resembles this expression. So we're going to say x squared minus a squared is similar to x squared minus 4. We can quickly see that our a squared is equal to 4, meaning that a is equal to 2. After identifying this, we want to assign what our substitution value is going to be. In this case, it says x is going to equal a secant theta. So x is going to equal a secant theta. We are now, since we already know the value of a, we can substitute it in, giving us x equals 2 secant theta. The next thing we want to do is solve for dx. dx will be 2 secant theta times tan theta. The next thing we want to do is we want to simplify this using what we know. So we can write this expression as 2 secant theta squared minus 4, which can be rewritten as 4 secant squared theta minus 4. If a 4 is factored out, we can write secant squared theta minus 1, which gives us 2 tan theta. We know this because we know the identity secant squared theta minus 1 equals tan squared theta. And the square root of tan squared theta is just tan theta. So after we have all these values, we can plug them back into our integral. So our integral, which is originally dx over x squared minus 4, we can rewrite it as dx, which is 2 secant theta tan theta, over x squared, which is 2 secant theta squared, times the square root of x squared minus 4, which we solved as 2 tan theta. If we expand it, we'll get 2 secant theta tan theta over 4 secant squared theta times 2 tan theta. We can start to cross off the similar and simplify this fraction. Secant theta, giving us the integral of 1/4 secant theta, which we know will be equal to 1/4 cos theta plus, the integral of 1/4 cos theta, which will equal 1/4 sine theta plus c. However, we can't keep it as sine theta. Instead, what we're going to do is, since we know that x is equal to 2 secant theta, as we said right here, we can rewrite it as x equals to 2 over cosine theta, giving us cosine theta as 2 over x. So if we assign this angle as theta, then we know that cosine of this angle is going to be adjacent over hypotenuse, which would be 2 and x, meaning that this side would be x squared minus 4. Therefore, sine theta would be opposite over hypotenuse, which would be x squared minus 4 over x. Knowing this, we can plug sine back into this equation, giving us 1/4 x squared minus 4 over x plus c as the answer to our integral. Thanks for watching. I hope that helped.